before we can now deal with descriptive statistics and introduce concepts like median, mean, and standard deviation, we first need to address what data actually is. And we will start by describing what features are in detail and thoroughly. Feature, or as it is often used in English, is exactly what the feature M is. In the end, it is about what it is all about. So what they measure, what they try to observe or capture. So when you measure temperature, then temperature is the feature. If you want to measure other things, then they are other things. But exactly, the feature is precisely what it is all about. And we can now further subdivide this into different types of features. There is, namely, a qualitative feature, which means that we do not measure anything with numbers, but rather in categories. So, for example, you measure a color, red, blue, green. Of course, you can also measure colors numerically, or they measure what types of animals are visible in the forest throughout the day. These are therefore categories or classes. And the problem with qualitative features is that we actually cannot perform calculations with them because we always need numbers. And therefore, in 21, the next feature, namely the quantitative feature, will play a much greater role for us. And that is precisely it. A quantitative feature is therefore anything that we can name with measurable quantities. That means they are numeric values. And with that, we can perform calculations. Therefore, this is something that plays a larger role for us. This can then be further divided into so-called specific discrete features. These are features that can only take certain values. For example, school grades. School grades cannot have arbitrary decimal places, but only 1, 2, 3, 4, 5, or 6. That would be one possibility. Or rather, money. Money also only represents discrete values. 0.01 is the smallest currency that exists. And then there are basically continuous features. These are features that can take any values. And these are things like size or weight, for example. Everything that can be specified with arbitrary precision can become 2001. And we will actually deal with both things. Discrete values are always a bit easier because we often work with sums, and with continuous features we then need to introduce integrals. But we will get to that over the next few weeks. Exactly, so those were the distinctions in various characteristics. And now let's take a look at what data is. Here we can also distinguish between two different types, namely univariate data and multivariate data. And yes, uni contains the word one. So these are data where we examine only a single characteristic at a time. So imagine we are only considering the temperature and nothing else, not the wind strength, nor the solar radiation, but only the temperature. And now let's take a brief look at how we can describe this formally. We start a bit from right to left. This means, first of all, that our value lies in the real numbers. So in r to the power of 1, we could also say, lies our so-called xk. So what univariate data are is a sequence of numbers that we can call xk, where k ranges over an index set. That sounds more complicated than it is. Imagine we have 4 data points. Then the index set is nothing more than 1, 2, 3, 4. And then we have our data points x, x, and x. And each of these x to x are then real numbers. So we measure a value at the beginning, then another value, then another value, and then another value. And that could then be 1, 4, 5, 7, Or I have another example here, school grades. Yes, that would be a series of school grades, which would be univariate data. In contrast, there is multivariate data, which refers to data where we look at multiple characteristics simultaneously. This means that if we now go from left to right, from right to left, our xk is no longer in r to the power of 1, but in r to the power of m. This means that we are looking at m characteristics. And then we have a sequence of xcars again, we have a sequence of xcars again. And we have an index set that describes how many data points we are looking at. And here we have an example, namely, we look at the rent and the size of an apartment at the same time. And so our m, the number of characteristics, is equal to 2. And then we have here a sequence of numbers, or rather vectors, and in each vector there is the rent. Yes, that is this here, and the size, which would be the second number, so 1085 square meters. The next data point is 1203 and 90 square meters, and so on. This means that these are multivariate data. Sounds more complicated than it is? Yes, what have we looked at in this video? We looked at what characteristics are, specifically the difference between qualitative and quantitative. Quantitative is what interests us. What can we transfer in discrete and continuous forms? And then we looked at data that we can distinguish as univariate and multivariate. And now, in the next step, we can describe the first characteristics of descriptive statistics.